Hello guys, welcome back to my channel. So in the previous lecture we have studied about what solid principles are. Like we have studied that what is solid means and why do we need the solid principle and what benefit it gives us. And we have also studied like what each characters in the solid means. So in this lecture we are going to study about the first character of the solid. So yeah, let's start this video. So the S stands for the single responsibility principle. In the short form, we also called it as SPR. So what does SPR means? It means that a class should have only one reason to change. In simple words, we can say that a class should do only one job. It's not a quite a good word, but we can also say that each class should do only one type of job. Okay, so the each class should do only one type of job, and it should also avoid the high coupling and it should have the low cohesion. So what does this means? That it should have high coupling, it should avoid high coupling and have low cohesion. So the high coupling means it should avoid high coupling means that it should avoid a class should avoid too many dependency on uh, too many dependency on the single class. We should avoid the too many dependencies on the single class. So a single class should does not have multiple dependencies in it. And the low cohesive means a class should focuses on a single task. Let's say if a class let's say if we have a class which do only a single class. Let's say it have a functionality of on off, so it should do only on off. It should have a feature related to it should have a code related to on off functionality only. It doesn't have it doesn't have too many other functionalities in it. Okay, so yeah, so now let's go to the second slide. So the next point comes in our mind is like how can we deduct the SPR violation? Like how do we know? How do we get to know that our code is violating the SPR violation, SPR principle? So there are several factors by which we can analyze it that our code is violating the SPR principle. So if a class have too many unrelated methods, okay, if a class have too many unrelated method means that if a class, let's say if a class have 10 methods, but only 6 or 7 methods uh, are related to the class, other 3 methods are related to the different class or different feature. So by this we can say that it is violating the SPR principle. And changes in different parts of the app requires changes in the same class. So yeah, I have already explained this. Let's say if you are changing the same class for the different feature. Let's say you are working on a feature A, you have changed the class A. Now after some time you are working on a feature B, but now you are again changing the same class A. It is quite possible that feature A and feature B requires the same class, but the different code, but the different let's say different method. You are should not be a factor to change your same class. Okay, so the next point is class is handling both business logic and infrastructure logic. Let's say a single class is working, let's say you have written us in a business logic and the DB related logic in a single class. So by this also we can say that your code is violating the SPR principle because you have written a class. It should it should only do it should have only either business logic or have a UI logic. Okay, so we can't combine both, otherwise it violates the SPR principle because it now this class is responsible for the two job, for the business logic as well as infrastructure logic. So yeah, so now let us see the code. How does this looks in the code? So we are going to see first a code that which is violating the single principle, uh, you can say, which is breaking the SPR principle. So we have this code that is we have a class name invoice. Okay, just wait a minute, guys. Huh, okay. So as you can see that we have a class invoice and it have three different methods. Okay, the first method is calculate total. So in this method we have a logic which will calculate the invoice total, which is responsible to calculate the invoice total. And we have one another method, print invoice, which is responsible to print the invoice. And we have one more method which is responsible to save the invoice to the database. So now what problem does this code have? So it have two major problems. As you can see, the first problem is that the invoice class have three responsibilities. The first responsibility is that it should be able to calculate the total, it should be able to print the invoice, it should be able to save the invoice to the database. So now let's say if you have let's say if you have to do some changes in the you can say let's say you are modifying the print invoice logic. Okay, you are doing some modification in the printing logic. So you will come to this class and you will do some modification, you will write some modification logic to this code. And after sometimes, let's say you need to change some logic for the calculation part. Okay, now let's say you are adding a tax, or you are avoiding the tax, or you are adding some different type of taxes. So you will again come to this class and you will modify this logic. And let's say now to if you have to change some logic, let's say you need to add some filter before saving, you need to add some preconditioning logic before saving your invoice data to the database. So you will again come to this class and you will do the modification. So this class is clearly violating the SPR principle. How? Because by these three factors we can able to do a modification in the invoice class. So we should avoid this. The class should have only one modification logic. By only one factor we can able to modify this class, but currently we have three different factors. Let's say these three methods are the three different factors by which we are going to change the invoice class. So now let's say how can we avoid this? How can we avoid this? How can we refactor this to follow a single point responsibility principle? So now, yeah. So as you can see that we have only single class, and in the single class we have three different methods, and by these three different methods we were able to change this class. So it should we should avoid making code like this. Okay, so how are we refactoring this? We are making three different classes for three different functionalities. Okay, basically these are three different functionalities only. So we have one class which is responsible to calculate the total of the invoice. We have one more class which is responsible to print the invoice, and we have one more class which is responsible to save the invoice. Okay, so how does it solve our problem? So as you can see that each class has only one responsibility. This class is responsible for the calculation logic, this is responsible for printing, this is responsible for saving the invoice. And let's say in the future you need to change the logic for the calculation, you want to add some taxes, so you should do only change in this class only. You do not need to touch these two other classes. Okay, and let's say if you want to change the logic in the printer, so you will come here and you will change the logic in the printer class. So by this we can say that we have successfully transitioned our we have successfully refactored code which is not following the SPR principle to which is following the SPR principle. So in if I can summarize it, basically the SPR means that for every functionality you should make a different class. Okay, for a class should not have two different factors by which we can able to change the class. Okay, it should have only one factor. What does I'm repeatedly saying the factor. So what does factor mean? The factor basically means the methods. Okay, these are the methods. So we these are the factor: calculate total factor, print invoice factor, save invoice. So these, so by this we can say that we have successfully modified our code to follow the SPR principle. Okay, so we have seen one example. Now this is for you guys to visualize it. How are we breaking our code to follow the SPR principle? Previously what happening was that the invoice class is responsible to calculate the total, it responsible to calculate the responsible to print the invoice, responsible to save the invoice. But after following the SPR, we have break this logic into three different classes. So this is responsible for calculation logic, this is responsible for printing the invoice, this is responsible for saving the you can say saving the invoice. Okay guys, so okay guys, this is it for this video. In the next lecture we are going to see this open and close principle. So I hope you are able to understand this SPR principle. If you have any doubt related to this single responsibility principle, so you can mention that in comment box. I will try to help your queries. And if you think my pace is fast, or if I should add some other teaching methods by which you guys can easily be able to understand, then please do a comment so that I can you can say make myself better. So thank you guys, bye.